In this video we're going to take a look at some of the challenges from the Hacky Holidays Space Race 2021, and the competition started today, 2nd July. It's running for 3 weeks. If you're watching this video, the competition's over because obviously I can't post solutions to the challenges while it's ongoing. But if you're interested next year, you can apply. It's teams of up to 4 players. You can get prizes for student teams, non-student teams, the best write-ups and video write-ups, etc. And basically it's a CTF competition. We've got the usual kind of categories: Misc, reversing, web, network, crypto, and there'll be new challenges released each week. So we have these 3 phases. A little bit more information here: rules, don't be brute forcing the network, etc. And that's about it really. So I've got a team together here just with a couple of students from the master's course in my university, and I've done the initial teaser challenge here, so let's take a look at that first of all. So the first teaser challenge is a web challenge, and the description says: you arrived at the launch platform of Space Race. Teams around you are preparing for the event the best they can by gathering their crew and designing their flag. At the outset of the camp, you notice the Hacky Holidays admin base. You decide to stake out and see what's happening. After a while, you notice that people are only allowed to access the admin base when they show the Hacky Holidays admin flag below. And then we have this PNG file, so let's open that up. And this gives us a flag that we can have a look at. We've also got a little bit more info here. It says open the flag designer and see if you can hack your way into the admin base. Only the URL and this following URL are part of the teaser challenge. So we can go and open this up. That URL doesn't quite look the same as the one we have here, so let me just... oh, there we go. Alright, so we've got a flag creation page here, so let's have a look at our flag. We've got 3 lines here in the background, so yep, that's good. Our colours, let me actually move this out of the way a bit so we can see it, and oh, now we can't see our actual flag there. Okay, there we go. So we've got a dark orange at the top, and then a light orange, and then a yellow. And then we need to sort out our overlay here, which is it number 11, number 12, number 9, this little spot down here. And the color of that, yeah, it's on the right color already. And then we have another overlay, which is this pattern that we need then. So we'll cycle through these. We've already got the color correctly. If we actually cycle through those, we'll find that there isn't a symbol matching this. So what we want to do there is, or what I did here was just inspect the 14th element. And if you actually do that, you'll see that we've got 14 buttons here, and then we have this one you can see is grayed out. And what we have here, button class, button primary active, right here we have button primary D-none. So I'm going to change that and say active as well. I'm going to close down the dev tools and change that to 15, and there we've got our flag. So that's the first challenge. So with the first teaser challenge out of the way, we'll start phase 1, and you can see here, here's all the challenges that are currently available for us in phase 1. The rest will be unlocked in 7 days basically. So our first, we have a teaser challenge in phase 1 which is called Locked Out, so let's go on to that first of all. It's a cloud challenge, and if we take a look at the description there, it says: after a relaxing spacewalk, you realize that you have been locked out of your spaceship by the spaceship's AI. Thankfully, you remember that you prepared for this eventuality by storing access keys in an external storage. And then we can see here that 25 points, obtaining external access keys. Open the external storage and see if there's something useful in there. So we can open that up. It's an Amazon Web Service here, an S3 bucket, and if we have a look at the XML content we've got here, we can see that we have this key to external spaceship storage.txt. So let's just try and access that in the browser, and it gives us access to the file without any issues. And in here we have the first part of our flag. So I submitted that. I'm not going to submit it again because it takes a long time just to come back and say you've already submitted this flag. But that's the first part of our flag, and then we also have some more information here. So we've got these 2 values. Let's go to the next part of the challenge though, see what it says. It says you've managed to get keys. See if you can get inside and check the internal spaceship storage. So it's telling us that these are keys. I don't know much about AWS, but if we search AWS keys in Google, and just have a look at some of the documentation. We can just go and verify what kind of format we expect to see them in. So for example, here we have access keys, consists of two parts. We have the access key ID and then the secret access key. And if you look at what we have here, it looks remarkably similar to the access key ID and the secret key that they have. There's also information about how to configure these stuff here as well, so you can go and look through that documentation, but we can do this through the command line. So let's go to AWS. Oh, I actually need to install it. Sudo apt-get install AWS CLI. Once that's installed, then we can do AWS, and I'm going to do configure. It's asking us for an access key ID, so that's the first part. Paste that in. It's asking us for the secret part, which is right here. Paste that in as well, and then region name, we could leave that as default, but it's also available to us here, EU West 1, and I'll leave that as default as well. So now we've configured that. If we do AWS S3LS, then now we see that we have our external, which we saw already, and we also have this internal as well. So let's try and list this directly. Let's do AWS S3LS and list the internal storage, and in here we have another file called spaceship keys. So we want to download this basically, but if we tried to access this through the browser, let me just show what happens here if we just update our URL to the internal. Update that to internal. Let's update this spaceship keys as well as the file name, and you'll see that we get access denied. So because we don't have the keys set up here, we're not able to access that from the browser, but what we can do is AWS S3 CP S3, and then we pass in the S3 bucket and then the file that we want to get, spaceship -keys, and I'm just going to copy that to our local location here. You can see that it's been copied. So now if we do cat./spaceship keys, and there we've got our second flag as well. The next challenge is called BowShock, and it's a reversing challenge. It says BowShock is an amazing phenomenon, but you better not get too close. And it also says, can you find out how to minimize BowShock and prevent everything from turning into dust? So we've got this jar file to download. I'm going to grab the link and then just wget to the desktop. Something you might want to just do first of all, just have a quick look at strings, something I pretty much always do. But we're going to want to go and have a look at the code of this. So there's quite a few tools that you can use. I'm going to use GD GUI here. Hacker 101, the CTF resources there have some good resources in terms of tools that you can use, and some challenges as well to try out Android stuff. So that's worth bearing in mind. But if we open up BowShock here, we can have a look and have a look through the manifest file. We can see here we've got this class, and then here's the bulk of our code. So we've got this class BowShock. Let's have a look at our main method and kind of trace this back. So, well, this is going to start at the beginning. We've got this get input. It's saying set the amount of plasma to correct the amount to the correct amount to minimize BowShock, and it's going to take a integer from us. It's going to take a number, and this total input is going to be incremented based on whatever number we provide. And then it's going to check, did the number we provide here, if get input, if the number we provided wasn't 333, then it'll call BowShock, and BowShock's basically going to print this out, say all dust is in the wind, now exit the application. So if we do enter 333, then it's not going to go to BowShock, it's going to go we survive another day, and it's going to loop back to this get input function up here. So essentially it's just going to keep looping through and asking us for numbers, and we need to provide these numbers in the correct sequence. And if we do that, at the end we'll get this victory, CTF BowShock to total input. So we don't really need to even run the program because we can see how this is working, right? So let me even, if we just open up, I'm bad at maths, so let's just open this up and do 333 plus 942 plus 142, 1417. So our flag is going to be CTF BowShock 1417. But just to show that as well, by running the tool, let's do java-jar BowShock, and you can see here it's asking us to provide an amount. So if we put in an incorrect amount here, 1337, we get that all dust in the wind. So we need to run it again, provide 333, and then provide 942, and then provide 142. And if we do it in that sequence, we get back our flag CTF BowShock 1417. So I've already submitted that flag, but that's two different ways that you could solve the challenge. Well, not really two different ways, because you still need to reverse, and you still need to have a look at the code to work out what numbers need to be entered here. The next challenge is called Unidentified Flying Object. It's a Stego challenge, and the description says, we've seen an unidentified flying object passing by. It was created on one of the universe's most advanced printers. And then for the first part of the challenge here, it says the UFO was forged on one of the universe's most advanced printers. Do you know which make and model? Answer in this format, make and model. So in previous challenges we've had to enter CTF with the curly braces, so just to know that that's a slightly different format. And then we have this G-code file to download, so I'm going to download that with wget. While that's downloading, let's go and have a look what is G-code, because it's not something I'd had any experience with really. You can see here it's the most widely used computer numerical control programming language. It's used mainly in computer-aided manufacturing to control automated machine tools and has many variants. So it seems like this is used in quite a lot of 3D printing software, so worth bearing in mind. Let's go and take a look at the file. Should be downloaded now. And it's a very big file, there's a lot of lines in it. How many lines? 490,000 lines nearly. So a lot more than I can really manage to read through. But if you scroll, well, I mean, I just kind of scrolled through this and had a look based on the way Sublime shows you the structure here. You can kind of scroll through and see if there's anything which sticks out. There are certain parts, but I don't really know too much about the syntax of G-code. So if we go down towards the bottom of the file, we do have this these settings which are enabled, and in here I notice the GTEC A10M, which if we go and Google that, we find that that's actually a printer make and model. So if we submit the first flag as so, well, I can't submit it again there, but that was the first flag anyway, the make and the model of the printer. And if we go to the second part, do you know how G-code files work? Maybe you can find a hidden message along the layers, and this one does have the usual flag format. So in this case, I was having a look at some different tools that we could potentially use to run this code. You have some online simulators, but I did find myself that they were quite slow to run. So the tool that I ended up using to solve this was Camotics. Let's go and grab a copy of it. You see here it's an open source G-code simulator, and let's go and first of all want to get it downloaded. Here's the Linux 64-bit, so I'm going to download that. Installation instructions right here for Debian, so if that's downloaded we'll just paste that in, and that should be it installed. So let's try and run it. You see here we get this error about libv8, so there was a message here saying if you get missing libv8 then we'll need to run this, so let's also run that. And let's try and run it again. Looking better. There we go, we're getting a nice user interface up here. So I don't really know anything about this tool, but I know that you can run the simulation here. We can hit play and it's going to go through, or we can use this position at the bottom to manually do that. Let me just pause it. We can just drag the slider along and then it'll actually load as it goes, or we can play it, we can speed that up and slow it down. Let me speed it up, we can reverse the direction of it, etc. So we want to load our own code in here, so let's add a new file, G-code, and grab this from the desktop. I'm going to delete this one, and then we want to run the simulation. So we can zoom in just with the scroll on the mouse. We can use the left click to rotate it, and we can use the right click to move it around. So we want to kind of move this around a bit, try and get a good angle on it. And what I basically found here is just from going through the position a bit, you'll start to identify some text. So let me zoom in a bit more there. You can see that Ying underscore SA. Right, so keep going a little bit more, Ying underscore SA, and then we can see what looks like a C there. So this is really hard to see, but you can, if you move it, if you rotate it as you go, you can kind of see it a bit more. So you can see there's an F over here, S, A, we have the C here, and I basically just kind of played around with this for a little bit until I was able to identify that this is saying flying underscore saucer. I'm sure there's a far better way to do it because, well, I mean, the description here says, do you know how layers work? But I'm assuming that if you kind of understand more about how these files are structured, you would know what to strip out just to be able to retrieve the flag in a more readable way. But I mean, this got me the flag without having to spend a lot of time learning exactly how to modify this code. So I'll leave it at that. But I'll be interested if anybody solved this in a more professional way. Do let me know in the comments. The next challenge is called Enumerate in the Cloud. It's a cloud challenge, and the description says, the spaceship that you'll use in the space race is almost ready. One of the last steps is to verify that all the systems are operational. Unfortunately, the AI controlling the system information decided to take a personal time off for a few days, leaving you without any easy access to the spaceship systems. This is not a problem because, as a cybersecurity specialist in the ship, you know the spaceship cloud infrastructure like the back of your hand. And then a little bit more information about the first part. So this is a 5-part challenge. The first part says, your spaceship is located here. Can you find the external information panel? So let's open up the URL that it gives us. And this is taking us to this planet bucket, another S3 bucket like the last cloud challenge we took a look at. Let's have a look at the source code here. And if we view the source code, not too much here, but we have an image source which is linking to a different bucket. So this is rocket bucket instead of planet bucket. So let's take a look at that instead. Let's take the view source off. We're not interested in this image, so we'll just load the base directory. And in here we can see then we've got an external information panel.txt. We've got a flag.txt as well. So let's grab that first of all. This is our first flag. So we can open this up, grab that, and then as the first flag, so let's go on to the next section. The next section is saying obtaining the spaceship access keys. You've gained access to the external information endpoint. Can you access the spaceship logs to obtain the access keys? So let's go and grab this external information panel.txt as well and see what they've left for us. We open that up, we've got another URL here. This one is going to an execute API domain and to the logs directory. So let's try and access that. Oh, I didn't copy that properly. So we'll try and... oh. How strange. There we go. So we try and access this new URL. We get request method get is not allowed. Let's open up our developer tools here and go into the network tab, reload the page, and we'll just try and send this off as a different type of request. So we can hit resend here, edit and resend, and let's change this from get to post. send it again, and let's have a look and see what the response was of that. The response was post is not allowed either. So both get and post are being declined. Let's see if we can, just to automate, not automate, but to speed this process up a little bit, let's send this through Burp Suite. So I'll grab this request and send it to the repeater, and it just means we can try out some different methods, HTTP methods, without having to click edit and resend and stuff each time. So xpost isn't allowed either. We've tried get, we could try head. So that came back okay, but it's not giving us any extra information. We could try options. Not allowed either. Let's try put. And there we've got back some information, and in here we'll see we've got our next flag, so we could grab that and go and submit it here. Move on to the third part of the challenge, which says you've managed to access the spaceship. You see a cleaning bucket, the Lambda thrusters information panel tag, and the eSpace cloud computing system tags. What does the tag in the cleaning bucket say? So let's go back. I'm gonna open this up. Where is it? Burp Suite. Okay, I'm going to request this in the browser, so we'll go show response in browser, take a copy of that URL, and I just, so it's a bit easier just to read through this JSON file. So we have, this looks like a Docker config, and yeah, so we've got our first flag there, but we need to have a look for our AWS secret access key and our access key ID. So in our last challenge we were given these in one of the files, and we needed to go and input these into the AWS command line system. So let's go and try and do that now. So we'll go AWS configure, and it asks us for our access key. I've still got the last one in, so let's go and grab this new one. First of all, our access key ID, and then our secret key as well. We'll leave the other stuff as the defaults, and now let's see if we can just have a look. So AWS S3 LS, and we can list the different buckets that are available to us. So we've already looked at the planet bucket and the rocket bucket, but we've also got this cleaning bucket. So let's see if we can AWS S3 LS cleaning bucket, and you'll see there's actually nothing available to us there. Let's go back to our challenge info, and it says you managed to access the spaceship. You see a cleaning bucket, the Lambda thrusters information panel tag, and the eSpace. What does the tag in the cleaning bucket say? Alright, so what we can do here is AWS S3 API, and then let's do get here, just hit tab, and you'll see with the autocomplete we've got quite a few different options here, but one of them will be get bucket tagging. So let's do that, get bucket tagging, and we try to run that. It's going to say now you need to provide a bucket, so let's do that as well, and the bucket name is right here. So we paste that in, we get back some tags, and you'll see here Hacky Holidays users. We've got our next flag, so we'd take a copy of that and go and paste it right here, and then we'll get on to our fourth stage. So the fourth flag is saying what is the tag in the Lambda thrusters information panel. So I wasn't too sure what to look for here, but if we just go and search AWS Lambda, and we'll see that it's an event-driven serverless computing platform provided by Amazon as part of AWS. So this is another part of AWS. If we do AWS and then tab for autocomplete here, you'll see we've got a lot of different options available. One of them is Lambda, so we can go to Lambda and then autocomplete again. So if you basically play around with some of these options in here, let's go and try and list tags, for example. Doesn't work, we need to provide a resource. Let's try and list functions. Oops. List functions, and we list the functions. We get this another JSON file back, and in here we can see we have two different Lambda functions. One of them is this Lambda thrusters, and now we have the full name of that, and we also have this full function ID. So let's go back and see if we can now list the tags. We just tried to list tags, and it told us we need to provide a resource. Let's do -- resource, and let's paste that in, and you'll see that it's come back with our fourth flag, and then our next tag that we need to get is the eSpace Computing Cloud System. So grab this and go and paste it into our fourth flag field, and we're on the fifth and final stage, which is what is the tag in the eSpace Cloud Computing System. So this was another one that took me a little while to determine. I was kind of looking at some of the, well, it says Cloud Computing System, so I kind of took that as ECCS, and here we have ECS, but we also have EC2 and some of the things, EFS, the Elastic File System, a few different things it could be. I kind of played around with them for a while and eventually found that if we run AWS EC2 describe tags, then we get this final flag, and that's the challenge complete. The next challenge is a web and OSINT challenge called UFOria, and the description says, UFOria specializes in organizing your trip to space, get some tickets while they last. So we've got a system that we need to launch here. I'll start launching that in case it takes a minute to boot it up. This will give us access to our own instance. So it says here this challenge is intentionally vulnerable and you're allowed to find vulnerabilities. For more information, click here. This is basically just telling us about not brute forcing systems. But yeah, let's open up this link. We have two parts to this challenge. The first one says invite only. Can you get the valid invite code? The flag is the invite code. You can see my teammate already solved this, but I want to make some walkthroughs for the challenges, so I came back in to check it out myself. And if we do go in and check it out, we'll see this page, be an astronaut. We've got solo, crew, fleet. We can try and click on a few of these and see do they do anything. And you'll see actually when we click on the fleet one, we get this option is invitation only. Please enter invite code. So what I'm going to do is just have a look at the source code and see what's actually going on when we click that. You'll see there's this function which is created, var code. So it's taking an invite code from us. It's making sure first of all that it's going to be 12 characters long. If it is, it'll continue then to, it's grabbing a substring, so splitting this into three parts, whatever we enter. It's inserting a dash in between each part, and then it's going to check each part individually to see do they match these three things. So what I'm going to do, I'm going to go and open up the dev tools, and let me go to the debugger just so we can see the code as we're doing this. But essentially we know the first part of the key is going to be UFO because that's what it's checking for. The second part is this BTOA, which is basically base 64 encoding. So we can go and paste that in here and see that, alright, we need to enter UFO dash VUZP dash, and then what's the last part asking us for? The char code as well. So, well, we could work that out, but I'm just going to go ahead and take a copy of that. Let's paste it here, and it's 234. So we need to enter UFO VUZP 234, and we'll take a copy of that. Contact us, and then OK. So, yep, great. Please continue with the booking process. So we've got the correct flag. Now we just need to go and submit that here. And then the second part of the challenge is, can you access the members only area? So let's go back and have a look. So if we go to the members section here, and we have a login box. The first thing I tried here was just to enter an apostrophe in the password, see if we've got an SQL injection. Try some default credentials, admin. No luck. So if we go to the I've forgotten password link, and we'll try admin, recover, and we get username not found. So we've got a way to test whether a username is valid or not. And upon looking around the site a little bit, saw this Twitter and LinkedIn URL. The Twitter is just an alert box. There's not actually anything there, but LinkedIn will take us to the page. Unfortunately, we have to log in order to even view the page. I did try to find a workaround for this, or even some kind of disposable or shared LinkedIn accounts that you could just use the credentials for, but I didn't have any luck, so I'm going to have to sign in here, unfortunately. Just give me 2 seconds. Okay, and once we get logged in, we'll see here that we have this UFOria, be an astronaut. It's located Amsterdam. We've got 43 followers, 1 employee. Let's have a look at that. And a couple of posts that were put up here as well. So I had a look through the posts, didn't really see, there's a couple of comments, but it's mostly people asking for flags. doesn't seem to be put there by the author. We do have this LinkedIn member, co-founder at UFOria, and then there's another one as well. It's only showing LinkedIn member. For me, it originally was showing their names as well. So we can have a look at those if it allows us to. Doesn't appear to be in this case. Well, I don't know why it's showing just LinkedIn member here. You don't have access to this profile. Okay. Well, whenever I did solve the challenge, it did allow me to access that. The name is Elliot Talton. Let's see if, yep, there we go. We can open that up, and if we go back to the UFOria, back to our challenge site, and to the About section, what I found in here is a little message by the CEO, Ben Organa, or Borgana. So this is kind of a hint that the username format might be the first initial followed by the surname. And we've got a couple of names now. We have the Elliot Talton and we have Ben Organa. But if we grab this Borgana, and let me go and try to hit forgotten password, and then here we get answer to security question, what's your place of birth? Okay, so we can go back and have a look. What does he actually say here? UFOria started as a small 2-person company, but since the very beginning we were dreaming big. I can never forget the day when we decided to establish the pillars of this company with Elliot Talton in our trip to our hometown. That day will be with me until the end, etc. So we know that they're both from the same hometown, and the security question we're being asked is, what is your place of birth? So let's go and have a look. Elliot Talton, do they disclose their location anywhere? And we'll see that they shared a couple of posts. One of them is actually this one, visiting Lance Hughes Cafe reminds me of childhood memories. So let's take a copy of this. Let's paste that into Google. See where is this located, and just grab the location, paste it in here. We get wrong answer. Okay, let me try that again. Bourtange. I'm pretty sure that was the correct answer. Let me... Bourtange. It was, yeah, okay. And there's the password. So we grab this password, go and log in. Borgana, paste in the password, and then we get our second flag. The next challenge is called Space Snacks. It's a miscellaneous challenge, and the description says, find the answers to the treasure hunt to gain access to the cake in the Space Cafe. So we've got 7 parts to this challenge. The first part says you find a rotten apple next to a piece of paper with 13 circles on it, on some text. What's the message? So we've got this message here. It mentioned 13 there, and looking at the message, it's quite clear that a rotation has been done on it. So we've got the correct format here for the flag. It's all the standard alphabetical characters. So let's go and throw this into CyberChef and do a rot 13. Considering it had the 13 as the hint there, probably not going to need to do much. There we go. So we've got our first part of the flag, and let's go on to the next part. Second part, the Roman Space Empire. You find a page with Roman insignia at the top with some text. What could it mean? So we've got another piece here. It actually looks very similar to the last piece, doesn't it? But we've got jam here at the front of it instead of PGS. So I'm going to throw this in here, and we can rotate by some different numbers here. So there we go, 19. We've got CTF, the one true salad. That could also be -7, as that'll rotate to the same place. And let's go on to the third part. So it says you hear the heavy bass line of 64 speakers from the next compartment. You walk in and the song changes to writings on the wall. Could there be some strange code, etc.? So you can see that this is base 64 encoded. We've got the equal sign there at the end. Good sign. Although there couldn't be sometimes it could be some other base encoding as well. So that's worth bearing in mind. If base 64, if it really looks like it's base 64 but it doesn't actually work for you, then there's a good chance it might be some other base 60 or base encoding. So let's paste that in there. Base 64 decoded. We've got CTF. I like the buttery biscuit base. So let's go on to the fourth part. And here, if you've done challenges like this before, you'll recognize that quite quickly as Morse code. So there's a lot of different sites that you can do these conversions on, but let's just stay on CyberChef and go from Morse code. Get rid of this base 64 encode in. Paste that in, and then we get our next flag as well. And we'll go on to the fifth part. And the fifth part says, you're now in the Space Cafe. the cake is the container that should not be here. You see random names on all the containers. What will the Docker never name a container? Please enter it as. Alright, this is interesting. I didn't actually know this, but we'll just Google Docker never name a container. And yeah, you find an article here quite quickly, why boring Wozniak will never be generated as a container. So that's the answer anyway, it's boring Wozniak, and the reason is because there's a part of the code here which says if the name equals boring Wozniak, then it'll basically pick another name because Steve Wozniak is not boring. So there's the fifth part. Let's go on to the sixth part, and it says here there may be more cake. They ate the cake and left with a note with a secret algorithm to unlock the cake treasury. We saw it happening on exactly January the 1st, 2030. So it gives you this full date and time. Are you the visionary that can figure out the pin code? And here is the pin code generation algorithm. So we've got this generate pin function, and it's calling srand on the time 0. So it's going to get the current time, or well, the time since the time started in January 1970 in seconds, and then it's going to return the random. So that's giving us basically a seed there. It's going to return the value, but we know that their seed is essentially this date, right? So we can go and try and calculate that ourselves. So to demonstrate this, let's go and create a new file. I'm going to do new.c, and basically going to paste in the code that we have there. So we've got the generate pin code exactly as it is in the challenge, and then we've just included the headers that we need to in order to get the functions we need, the random and the time. And then I've created a main method here which is just going to generate a pin, and then it's going to print that pin out to us. So if we save that and let's compile it, gcc new -o new chmod new, and now if we run new, and every time we run it we're going to get a different value because we're getting, well, every second that we run it we'll get a different value. If we run it multiple times per second we'll get the same value. But what we want to do is find out what value did they get because they ran it at this time. So we can go to something like epoch converter .com, and we can actually just go and enter in this date. So the date was January the 1st, 2030. So we'll put in here 2030, the 1st of the 1st, and the time was 11:23:45. So 11:23:45 AM. We'll generate that as the epoch timestamp, grab a copy of that, and then I'm just going to go and update the C code so that instead of getting the time, the current time, we're just going to specify that as a time instead. And that's going to be our seed. So if we compile this again and run it, every time we run it we're going to get the same value, and this is our flag. So that's the sixth one. Let's get the final seventh flag. So we have this flag here. It says the treasury consists of cake hidden on stars in space. So we've got the space and stars stuff here. Let's grab a copy of that. I'll just go and throw this into the C file for now actually. And what I'm going to do is we want to find and replace. I'm going to replace the space with a 1, replace all, and I'm going to replace the star with the asterisk with a 0. Replace all, grab that, and let's go and throw that into CyberChef as well, and convert it from binary. So anytime you see whatever the encoding is there, it happened to be spaces and stars there, but it could have been A's and B's, it could have been 1s and 2s. Anytime you see only 2 digits, there's a good chance that you just need to convert it into a binary format and then convert it. There is a function in CyberChef so that you don't need to specify this as 0s and 1s. You could specify what the 2 values are, but I can't remember exactly what it is. It's just as easy to convert it anyway. The next challenge is called Deleted Flag. It's a pwn challenge, and the description says, deleted your flag, oops. And note, the remote system architecture is 64-bit. We've got a little bit more of a description here saying, we've removed your flag, good luck getting it back, and it tells us what format the flag's in. So we've got an instance we can launch here remotely, but we've also got the C file that we can download to take a look at. So let's try and get this working locally first of all. I'm just going to wget that. and let's open it up. So let's step through the code here and try and work out what's going on. We've got a main method, and we can see that it's going to open this flag.txt file, which is obviously of great interest to us. It's doing that with file open, fopen, and then it's going to remove the flag, which is not what we want, but although it's been removed from the file system, we know that it's actually been opened into this file pointer right here. And if it successfully removed the flag, it's just going to say so we can continue, otherwise if it failed to, it'll exit the program. It's going to print out another statement saying about removing the flag, and then we have this buffer which is set up. It's calling mmap to let's go and have a quick look at some documentation for mmap. So mmap is used for mapping between a process address space and either files or devices. When a file is mapped to the process address space, the file can be accessed like an array in the program. This is one of the most efficient ways to access the data in the file and provides a seamless coding interface that is natural for a data structure that can be accessed without the abstraction of reading and writing from files. So we can see here that the parameters that it's taken in. Let's go and see what we actually have here. The first thing is the address. We have this set to 0. We have then the length, so it's reading in 4096 bytes. Protect, so what kind of access is permitted. So we have here maybe the following flags: read, write, exec, or none. In this case we've got read, write, and exec. And then we have flags here set, so we have the anonymous and the private flags. Anonymous, this is used to create anonymous mapping, means that mapping is not connected to any files. But then we also have the private. When this flag is used, the mappings will not be seen by any other processes, and changes made will not be written to the file. Finally, we've got a file descriptor, -1 here, and then the offset as 0. We then have this void function sc, which is taken in the buff, and then we have this read, which is occurring into the buff. Okay, so it's going to take some input off of us here, and it's going to put it into this function, which you can see down here. Sc is called down here, so whatever we actually enter here is going to be executed as directly as code, or whatever we enter here, whatever's read in here. We have the setup setcomp, which occurs before that as well. So the setcomp rules are set up here. I've only dealt with these setcomp protections in one challenge previously, was the blacksmith challenge on Hack the Box. But let's have a better look at that in a second. You can see the send file is mentioned here, but we'll go and run the setcomp. We'll go and run the application with setcomp and see if we can get a better visualization of what's going on. So if we want to try and compile this here, let's do gcc app.c output to app. You'll see that we get this error here about setcomp. We actually need to compile it with -l setcomp. And then you see I also get another error because I also need to sudo apt get install libsec comp dev. So we just need to get this installed, and then this should compile okay. Let's try and compile it again. So it compiled without errors. We could have a look at the security protections here, but I guess it doesn't really matter too much. We don't have any buffer overflows or anything that we're exploiting, so we don't particularly need to worry. Let's see if we can run the program then. Run the program, you see we get goodbye flag, error, removing the flag file. So because we don't actually have this flag.txt on the file system, it's not going to be able to remove that. So why don't we try and say echo fake flag to flag.txt, and then try and run it again, and you'll see this time we've got flag file successfully removed. What do you have to say about your precious flag? So we could enter something in here. We get a segmentation fault because remember, whatever's being read from our input here is being executed as shellcode basically, and that's not, we didn't enter valid shellcode there anyway. So let's have a look at the setcomp rules here. Let me create this flag file again. I'm going to run sudo setcomp tools and then dump, and then we'll run the app. You'll see here it asks us again. I'm just going to say same thing again, and you'll see this time it's jumped into this kind of if statement here. So we have some conditions essentially, and if this isn't allowed, then the process will be killed. So you can see here, if the address space is less than, it's going to jump down to 5. If it's down to 7, where 7 is kill. Okay, so if any of these conditions are met, if the architecture is not correct, it's going to jump down and kill the process. If the address space isn't in the right range, it's going to kill the process. And then finally, if the function being called is not send file, it's going to kill the process. So it's only if all these conditions are met, okay, that it's going to get to this allow, which is what we want. And this basically means that we're only going to be able to use the send file function call, which we'll need to go and have a look into now. What I'm going to do now is copy over a Pwn Tools script which I use. So you can grab this from my GitHub if you're interested. A lot of people find that it's unnecessary, but I like it. I'll explain why in a second. For this challenge, it's probably a little bit overkill. We don't need this function here to find the offset of the instruction pointer because there's no buffer overflow. But we'll take that out, take out some of this kind of boilerplate code. And the reason I like this is because whenever you run the program by default, it's just going to run locally. But if we pass in GDB in capital letters afterwards, it'll call GDB and call whatever script we have here. So we can set up some breakpoints. We could try and find out what the pi base is, or break RVA from the pi base. And I think it just speeds up debugging. But if you provide remote in capital letters with a server and a port, you'll be able to swap between local and remote very, very quickly. But we'll show that anyway. Let's just update the file name here, and because we have our context.binary being set, it means throughout this script we don't need to worry about address types and shellcode and stuff like that. It's going to know that we're dealing with a 64-bit Linux system, and we won't need to deal with that. Let's also set this to debug just so we can find out a little bit more of what's going on. And we know that we need to create a flag.txt, so every time the program runs, it's going to delete the flag.txt. We don't want to have to create one manually every time, so let's just create one here, fake flag, and this is what we're going to be trying to steal then. We can also save our payload, so let's just, for now, we'll just say the payload is equal to some A's, and then we'll save that to a file. Later on, once we get the payload working, it means that we've got a payload that we can just send off to the Netcat server if we want, or just send it in locally. And what do we want to send the line after? So if we create, let's do our echo flag to flag.txt, and if we try to run the program now, you'll see that this is a statement it gives us. So we can just take the question mark, but I'm going to take that flag question mark, and we'll say that after you receive that line, send the payload. We'll get rid of this receive until, we'll just go straight into an interactive shell. And let's go and test this out and see if it's functioning. So we run Python exploit, and you can see our debug is showing that what we've received here, it's sent off these A's, and then we've got an end of file. Nothing interesting's happened because we got a segmentation fault. You can see we got that core dump because we didn't send it any valid shellcode, so that's what we need to sort out next. The only thing is, we know that in terms of our shellcode, we can only use the send file function. So if we go and have a look at send file and the syntax of it, we'll find that it copies data between one file descriptor and another. Because this copying is done within the kernel, send file is more efficient than a combination of read and write, which would require transferring data to and from the user space. And it takes a out file descriptor and an in file descriptor, the offset, and then the size and the count. So if we go back to our code, we know that this has been opened into a file pointer here. In Googling around a little bit, what I did find was we know that we have our 0, 1 and 2, which is our in, out and error outputs, but I found in here just somebody mentioning that using 3 would convert a file descriptor to a file pointer. So let's just go and test this out locally. We'll go back to our exploit code, and we'll update our payload here. So the payload will be equal to ASM, so we need to convert this into shellcode. We'll do shellcraft.sendFile, and then we can provide our parameters. So we have, at the beginning it was the out file descriptor and then the in file descriptor. So out, we want this to go to the standard output, we want it to be printed back to our screen, and then we'll try the 3 file descriptor to read in that file pointer that was opened. And then I just left this offset at 0, and then in terms of the amount that we want to read, this doesn't really matter. Well, I mean, it depends what size the flag is, but I just took this as 4096 from here, but you can use a lower number without any issues there. And we're writing that payload. That's great. Let's go and test this out locally. We test it out locally, and you see that we've actually printed out the fake flag, which is exactly what we'd expect. Just to show then, in terms of the GDB, if I now run that again and type in GDB at the end, you can see that it actually opens up another window. I have that breakpoint set to file open, which means now we can just jump in, we can start having a look around at the stack and the registers, and it's a good way of debugging, because now if I want to run this again, I don't want to go and update my code to say I'm not using GDB, I can just take away this GDB, run the tool again, and we get our flag back. And it also means that whenever we go to try this remotely, let's go and just launch this server. We're going to try and launch this remotely, take a copy of this address, and then without having to update any of the code at all, I'm just going to type in here remote in capital letters, paste in that address and port, remove the colon, and then send that off, and that sends the exact same exploit off. But you'll notice that we didn't get a flag. So you can see here, this is the shellcode. You can actually see the shellcode that's assembled, and this is a good way to try and learn what instructions map to different function calls. But the reason this didn't work anyway is to do with this file descriptor, and I'm not 100% sure why. I did a bit of googling around, but if we increment this to 5, it seems to be something to do with the setup they have on the server. I'm not 100% sure. Something to do with maybe it being a child process. Maybe somebody can let me know in the description why that had to be updated. But if we run that again with that set to 5 instead, you'll see this time we get our flag. It's a 32 hex flag as we expected, and then we can submit that. The next challenge is called Knock Knock Knocking on Shuttles Door. It's a web, PrivEsc and network challenge, and we've got a back-end system we've got to launch here. We've also got this word list to download, so let me take a copy of that, download it to the desktop. We might want to have a look and see what's actually in there. So it looks like a password list, but let's see what we've got to do here. We've got to download a VPN as well, so I'm going to take a copy of that. Actually, it's not going to allow me to wget that. I've got to use the auth key here. So download that, and let's start the VPN. And then check to make sure we've got an IP address, which we do. So that's looking good. So the first part of the challenge here says we found a web server at 10.6.0.2. You may need the word list attached to this challenge. Which doors should I knock? Note, enter them as comma, so it looks like we need to find some port numbers here and then enter them in as the flag. This is the address that we've been given to access. So now that we're connected to that VPN, we should be able to access it in the browser. So we're through to the International Hacky Space Station, and we have a link here, take action, which doesn't seem to take us anywhere of interest. We've got a email address. Let's have a look at the page source, and we have a lot of JavaScript in here. This seems to just be some stuff from libraries. I'm not going to look into it into too much detail. You can see it looks like quite a bit of obfuscation there, but we've been told that we might need that word list. So the first thing I'm going to do is just go and see if we can do some directory and file discovery here. So I'm going to run gobuster dir for the dir mode, and let's go -u for this URL, and then our word list is challenge word list. So I'm just going to run through that. It's quite a small word list anyway, 999 words. and you see that we get to this link, who is there. So let's go and open that up and see what's going on. We've got a directory here with an Open Sesame file inside it. So we open that up, and then we see it would be a TCP SYN to knock all the doors of the airlocks. And we've got these 4 port numbers, or these 4 numbers anyway, and if we go back to our challenge, we can then enter those in this flag format. The next part of the challenge says, do you have remote access yet? Gain remote access to the system using that open door. So let's go back and look at those ports again. And essentially the idea here is that if we knock on these ports in this order, we should be able to open up a new port that we'll be able to connect to. So just before we go and look a bit more into that, let's start an nmap scan. I'm going to do sudo nmap, run this against all ports on the IP address. We'll put this on verbose just so we can see as it's coming through. And basically we know port 80 is open, but we're not expecting probably to see any other ports open here, because what we're doing at the moment, or what we're about to do, let's go and Google port knocking. So we'll see that in computer networking, port knocking is a method of externally opening ports on a firewall by generating a connection attempt on a set of pre-specified closed ports. So it's been configured that if these 4 closed ports are knocked on in order with a SYN packet, then you should open up some other predetermined port. We're not going to know what port that is, but there's a few different ways we can carry this out, and then we can go and check this out. Now I do know what port it is because I've already completed the challenge, and I can say that this scan does take quite a while, and it's not a high port, so it's probably not found the port already. But let's go and prepare some of the commands anyway for doing the port knocking. We could use something like knockd and use 10.6.0.2 and then pass in the ports 1337, 6861, 78. We could also use knock, so we can basically use the same syntax, knock, and then pass in those ports. Or we could do it with nmap. There's plenty of other ways that we could do it as well, but we could say for x in 1337 686178 do nmap, and then we need to set max retries to 0. And essentially we'll just be looping through here, so it's going to loop through and loop through each one of these items, assign it to X, and then it's going to run this nmap scan against X. Oh, one thing I did miss there was the IP, so it would be 10.6.0.2. And all of these ways should work for us. Let's go back here and see. So we're about probably about 50% of the way through the scan. We haven't found the open port yet, so I'm going to go ahead and I'm going to just use this knock here. I don't want to use multiple, because if there's any problems with the order that they go in, then we're not going to open up the port. But after we've done that knock, we can try and run the scan again. And you'll see that it's discovered port 2021 now on that IP address. So let's go over and try to connect to that on Netcat. 10.6.0.2 2021. Doesn't look like anything's happening, but if we try to list the files, we'll actually see that we've got flag.txt right here. So that's the second flag completed as well. Let me close a couple of these windows down, and we can stop the nmap scan. And now if we go back to the challenge and see the third part of it, it says, can you gain further control? So it sounds like we need to escalate our privileges. If we go back here, you'll notice that we can't tab autocomplete, and if we type something in, we can't move back and forward. So we want to try and make this a more interactive shell. I did try connecting back through Netcat, but we don't actually seem to have Netcat installed. Also, I'll try and run Python here. So we don't seem to get much, but if we actually have a look in the bin directory, we do have Python 3 available, so let's try and run bin python 3, and we could try to connect a reverse shell here, or let's just try import pty spawn bin bash, and that's looking better. Now we can do Control and Z, stty raw dash echo, and then FG to bring it back to the foreground. And now let's export a term equals xterm so that we can clear the shell. Now we can clear, and now if we try to autocomplete, you see we've got exactly what we'd like to see. And we can also now go back and have a look to see are there any other accounts, which there are. We've got this control account, which is obviously the account we need to connect to. So honestly, I spent a long time enumerating the system and trying to look for passwords and stuff. Try sudo-l first of all. We don't have the password for space otter. Again, we're not going to be able to go to control because we don't have the password for that either. So we could go and have a look around what about the web directory? Was there anything there that we didn't know about? But we don't actually find anything. Let me just go back a second and just go into the log. In here we have the NOCD log, so this is where we can actually see the stages of providing the 4 ports, and then it calls Open Sesame, and it's running this command, so it's using SOCAT to connect to open up this port 2021, and then whenever we connect to it, it's connecting us as Space Otter. Obviously we want to escalate our privileges to not to root in this case, but to control. Let's see if we can even go to cd home, cd control. No, we can't even list anything in there. Try and go to root, can't list anything there. We could get some scripts to go and copy over. In fact, whenever I was solving the challenge, I did copy linps over and run that. If we do that, we will find, we don't see anything here with the cron tab. But we will find a script which we can overwrite. So in the opt directory we have this safetycheck.sh, which if we take a look at it, in fact, let's also have a look here. So this is owned by root, but you can see it's world writable. So we can modify this, and presumably then this is being executed by root periodically. So let's try and run the script first of all. Try to run it. You see we get here oxygen is A-OK. So whatever condition is happening here, we're meeting this one. So why don't we just try and modify the file. We'll go and take out this line, which we know is being executed whenever the script runs, and we can go and put something else in here. Because I know that the Python shell seems to work, I'm going to go and grab let's go Python reverse shell cheat sheet. Go and grab a nice one-liner here. Python. Okay, this one looks good. We know we've got Python 3 here, so let me just go and modify it with our IP address. And we'll basically set this up to connect back to a reverse shell, which will hopefully then be running as a privileged user. Set this to 1337. We know this is Python 3, so I'll just take a copy of that reverse shell, one-liner, and let's go and paste it into Nano. Write out, save it, and exit. Oh, we should be setting up a listener here, and see -nlvp 1337, and presumably then this script is running maybe once every minute or so, and we should then get a reverse shell. Okay, so it took a long time actually. That must have been close to 10 minutes, but we did get a connection, and we now have our third flag pseudo to the moon. The next challenge is called Skylark Capsule. It's a web challenge, and the description says, we have the best capsules available for your deployment into space. So we've got an instance we need to launch here, and it's a 2-part challenge. The first part is called tokens. It says, get your capsule now, can you gain access to the capsule of admin? So let's go and take a look at the site that it's given us. It's called Space Race app, and it says, welcome space crew, this page will display the deployment specs of your capsule after login. So we might want to go and try and just log in first of all, admin, and we get this alert, say it's been denied. Let's go and try, just put an apostrophe in here, see if there's any kind of SQL injection. Might want to have a look at the source as well. Nothing of interest there. Let's go and try and register a new account. Now whenever I tried to register a new account, I actually created it as admin, and it allowed me to do it without any errors, but it wouldn't allow me to proceed to the next stage. So that's worth bearing in mind. Note that also if we go from being logged in to accessing the capsule and try to get specs, it says failed retrieving spec. So let's go and log out and then log in as that account, which I created just AA, username, password, and then try to access the specs again. And this time it successfully retrieved them. So let's go and see what actually happened there in Burp Suite. So we registered a new account right here. Let's actually check our login. So we got this 403 fail with the incorrect password. We went and created a new account, 200 OK, came back, sent off this JSON object with all our user details. And then whenever we tried to request the capsule spec, we got this JSON Web Token error. So it was expecting a JSON Web Token, which we didn't provide because we have no authorization token here. But whenever we logged out and then logged back in again, upon the successful credentials being entered here, we got this token back, which is our JSON Web Token. So then you can see whenever we actually tried to retrieve the specs, our JSON Web Token is right here in the authorization header. So we could take this over to, if you have the plugin installed, you can get this plugin for Burp Suite to enter the JSON Web Token right here and get some information about the algorithm that's being used and then the data that we have in there as well, which we can, well, we can also see that right here. So you can see our password has been turned into this negative integer. But we want to see, can we potentially modify this token? Can we change this so that we're actually the admin instead of A? Maybe we'll need to change the ID as well, maybe to 0 or 1. You would presume that the admin account is. So let's look at doing that. You should be able to do that in here, but I'm actually going to go to jwt.io, which is a site that I often use for this. And let's go and paste the token in here. You can see we've got all of our details, but you can see here we've got invalid signature at the moment. Let me try and update this to admin. You can see our tokens updating as we're typing. I'm going to change the ID to 1 as well, although I'm not too sure if it's important. Now you see it says here that the signature has been verified, but actually let's take a copy of this and go and test it out. So if we want to, we'll send this to the repeater. So we'll go and find the post request. Was it a post request? No, it was a get request to capsule. So I'm going to send this to the repeater. And then I'm going to just go and update this authorization header with our new one and send that off. And you'll see we get here invalid signature. So the issue is here, although for some reason it's saying that the signature is verified here, we do actually need to enter the correct signature here in order for it to be verified by the server. So how I solve this, let me go back and grab the original JSON Web Token here, and I'm going to go and just create, I'm going to go and put this into a file called hash, just paste that there, and we're going to use John the Ripper to crack it. So we'll say John hash, and then we'll pass it a word list, user share word list rocku, and we run that, and very quickly it comes back with this password, Skylark 140584. So let's take a copy of that and go and see if we can validate our new JSON Web Token with that. Paste that in there. I'm going to take a copy of this, and let's go back to our repeater. We'll send it off for this new token, and you'll see that we get back this admin account, and in it we have this flag as well. So that's our first flag, breaking them JWTs. We also have here, note the password for the admin, which is also a negative integer. So let's go back to, we can close down this JSON Web Token page now, and let's go back to the second part of the challenge, which is called hashing, and it says Skylark is making use of super safe non-cryptographic hashing algorithms. Can you log in as the admin? So we might try to search for the hash that we got for the admin, but It's quite an unusual looking one. Let's try and search for it anyway. Not what we're looking for. Let's grab the hash from the A username that we provided, and instead I'll search for this with the letter A. Nothing. Okay. Whenever I did this, I think I submitted it as ABC. So let's go and create a new account quickly. And let's create an account, ABC, register, let's log out, log back in, ABC, and then we need to get the specs, and let's go and have a look at those. This time we've got this password, it's not negative this time, and so this time I'll search for this and ABC, and you'll see we come back with this CRC32. So let's have a look, CRC32 hash, and we'll find some information about it. We'll see that it's not actually designed for hashing, and as was mentioned in the description of the challenge, it's a non-cryptographic hashing algorithm. So we're going to try and brute force this hash anyway. It's hopefully going to be easy enough for us to do. I will move it over to Hashcat on my host system just because it's a lot quicker than running it inside the VM. One thing we would need to do in this case, if we just search for Hashcat modes CRC32, you can have a look at it in the manual as well. Just to make sure you know what the mode that we have to set it to is, in this case let's go CRC32, it's 11,500, and then the format that it has to be specified as well is kind of you can't just put in the integer value that we have there, so you'll need to convert it into hex, and then you'll put in the hex value, and then it'll be followed by 8 zeros. That's the only way that I could get Hashcat to run it. So we need to convert it into hex, and we also need to be aware that it's currently a negative integer, so if we were converting ABC into hex it would be fine, but in this case we also need to do a little shift to convert it. So we can just run Python and then we'll do hex. Let me grab the password again. So we're going to convert that negative, and then we'll do modulo shift here, and this is the hex value that we'll be able to use. So the hex value will be provided like 0000000. I also tried to run it with the CrackStation word list and didn't get any results back for it. So let's see how we can get around that as well. So we've got the hash ready, so we can do here type hashes. And you can see that we formatted that like I just described a second ago. And the way that I eventually got to solve this was using a rule. So I'm going to run hashcat.exe, attack mode 0, and then the mode was 11,500. We're going to use these hashes, and then the rule was the one rule to rule them all, and then the word list I used was rocku. So I initially tried rocku, and then I tried CrackStation, which both run pretty quick as long as I'm not inside the VM, but neither of them got a result. But whenever I used the one rule to rule them all, I guess it reversed probably, or just maybe appended the 0 to one of the values. But anyway, this is the password that we managed to grab here, so I'm going to take a copy of that. Let's go back to the VM and let's go and try and log in with the new password. So we'll log in admin, I'm just going to paste that in, and there we get our flag. CRC32 hash collision successful. So there could be other values then that will result in the same hash there. That wasn't necessarily the password that was used, but we were able to find a collision. The next challenge is called MinesLazer. It's a crypto challenge, and the description says, "Can you clear our path? There appears to be a bunch of mines along our trajectory." So we've got a backend server that we need to launch here, but we've also got this .nim file to download. So we'll take a copy of the link, and there's only one part to the challenge. It says use your laser to remotely detonate all the mines. So we can download this nim file, and we can open this up in Codium or your IDE of choice. You'll see I don't get any syntax highlighting here, so let's go and see if we've got an extension that we can install. Here's nim language support, and if we install that we get some syntax highlights in here, and we can go and have a look through the code. We also need to compile it, so let me just see if I need to install. And then if we check the help options here, you'll see that we can compile it, so we can just run nim command, which is compile, and then our project file. So we'll run nim compile and pass in MinesLazer. You see it's managed to build that there. We now have a binary MinesLazer, so we can actually start running that. We start running it and nothing's happening, so let's actually go and take a look at the code, see what's going on. And if we have a look in here, you'll see that we have this process here to serve a connection on port 1234. So before even digging through the code and trying to work out what's going on, let's just try and connect to that with netcat. We'll put up another tab here, and then netcat localhost 1234. And you'll see here we get this use your laser to remotely detonate the mines. Are you sure? Let's just try and put in a command. It doesn't work, so let's go and see what the syntax is. And we can see here that it takes an input from us, which is line, and then it's going to split that into XY, which is splitting on a comma, and then it's going to parse those and make sure that X is between 0 and 8 and the same for Y. So let's just go back to the terminal and try and enter 0, 1, and you'll see here we've got bomb successfully detonated. Let's try and enter another position, 0, 2. So you can see that it's moving downways, moving columnways. Let's do 0, 3, and now we've actually we've hit something we weren't supposed to hit, and it's ended the game, and it's shown us what the correct answer would have been if we would have managed to get them all right. So we need to find out how this map is generated. We can see that we have the mines here generated using rand UINT64, so it's using a 64-bit random value to declare what the mines are. And if you go back and have a look at this, this is actually an 8x8 grid. So essentially this is a random value, and the way that the nim script works is it's calling randomize to begin with. Let's actually go and search for nim script random. If we open up some of the documentation, we'll find some basic usage. So we can see here that randomize is called initially to initialize the default random number generator. If this is not called, the same results will occur every time. So this is called, if we go back to our script, this is called at the beginning of the script, but it's not called every time a new client connects. So even though every new client is getting a new random value from this UINT64, the same seed is essentially being used for every client. And if we go back here, and we can actually see that the type of RNG that was used, I don't know how to pronounce this, XOR or Zoro Shiro 128 library, which if we go and actually Google this and try and get a bit of information, we can find some links about breaking the cryptography. So let's take a copy of this. Just search for cracking. You'll see that we can find some articles pretty quickly. And I don't want to go into the maths too deeply, mainly because I'll not be able to explain it very well. Let me just explain how I solved it based on this article. So this article here does explain a little bit about the algorithm that's being used. It's used in the Google Chrome browser, and it links to another. We've got another couple of articles here explaining how to crack it. We can have a look at the function as well. So this is the actual function that has the vulnerability, and this is an example of an attack to predict the next value. So taking a sequence, if we play a couple of games and we find out what is the correct sequence for say 2 or 3 games in a row, are we able to crack it so that we can predict what the next value is going to be? And as I say, the maths is explained in quite a lot of detail between these articles. I think particularly this blog post here on securityevaluators.com has a lot of details about the maths and stuff, but I'm going to skip that here. Let's go and have a look down here. There was a solution that was posted onto GitHub, and I essentially made use of this in my solution. So we can see here that it's talking about the random generator that we're about to crack, and if we want to get this tool running, we can do a pip install here. So I'm actually going to just set up the Python local environment. Let's do source pyenv2 and then pip install that, and then we'll also need to git clone the repo. Going to download that here. And here we have a couple of different things. We have that we can do a single shift. We also have the shift all. So the single shift will actually find the original seed if you want to try and find out what was the original seed. Shift all will find out the original seed and then all the variations that are going to come after it, which is what we're interested in. So if we can, as I say, feed it the last 2 game boards, the last 3 game boards, it should be able to then tell us what the next one is. So with the setup out of the way, let's have a look at the solution that I put together. So I created a couple of scripts here. We've got one called find sequence, which we'll take a look at first of all. And if we have a look here, essentially I've got this set to a client count of 3 at the moment, so you could change this if you wanted. We can set this up to, let's set this up to 10 just to take a look at it. And it's going to loop through then 10 clients. It's going to make a connection to our local server, and it's going to keep looping through until it loses a game, essentially making an attempt, because we want to lose a game. We want to lose 3 games in a row or 10 games in a row or whatever and get the correct output. So we'll try and lose a game, we'll get the output, and then this is me just replacing some of the stuff in there, turning it into binary. The same, you could probably do this in a far better way. I just kind of hacked this together. We need to reverse the order of some of this. This is just based on the way that the bits are tested here. So whenever this is sent through, it's going to call test bit and set bit and clear bit, and based on how it's using the LSB of the bytes, you just kind of have to do a little bit of reversing around. So I'll throw all this code on GitHub anyway, but we do that, we'll create then a unsigned 64-bit hex value, and then it's going to do that however many times we want to do it. Let me just put this back down to 3. However many times we want to do it, and then it's going to print out, and I've just got this set to print out with the Python script as well, just to make it very easy for finding the next sequence. So without further ado, let's test that out, and let me actually set this to debug mode just so you can see a bit more about what's going on. And then we run Python find sequence, and you can see here we've run, in this case, 3 games, but yeah, let's go and modify that and just test it out again. So in fact, let me just show you, whenever we set that to 2, we can run 2 games. We're printing out these 2 values here, and you see that we've got this command ready to copy and paste over to our other terminal where we have this xoro shift script. We try and run that, and you'll see here we get what we've entered there was the 8.2 value and the 9.8 value. So you can see here 8.2, 9.8, and then this is the next possible value. So the next game that we possibly run could be this one. But you'll also see that we have 8.2 and the 9.8 value here, and then the next possible game could be this one. So it basically depends how many games we play and how many values we have in the sequence as to how reliable this is going to be. If I go back and set this to 3 again, it should work every time. It should get a definite value every time. So let me take a copy of that and paste this in, and you'll see now then there's only one possibility. So we have our 8.2 value here, we have our 7e value, we have our b8 value, and then the next value is going to be this 5.2. The problem is, if we go and play another game now, then the next value isn't going to be the 5.2. So we have to be careful here that we go and solve this before we play another game. And it means that whenever you're trying to debug it, it just can take a little while. But in order to solve it, then let's see what else we've got set up here. We've got a solve game script as well. And you can see here the script's essentially going to take the value from us. So we've just been given the 4th value in the sequence. We need to provide that as an argument to the solve game script. It's then going to create a connection, a new remote connection to the server, and we're going to basically just play the game and enter in the correct values. So there's not really too much to that. It's quite a similar kind of loop that's going on to the last script. I should have really integrated these all into one script, but you know, I already spent enough time, probably more time than was required, just trying to automate this and playing around with Python. But yeah, that's the script. Let's test it out. So I'll go back to this window here. Let's do Python solve game. We paste in our value, and you'll see it runs the game. It predicted this board, and then this was the finished game solved. Let me actually go back and change that to debug. Put that on debug. Let's go and do let's do our find sequence again. So we've got a sequence of 3. Take a copy of that, go and paste this into our other terminal. We grab the 4th element in the sequence because we already have the first 3, and then we go and run solve game and just paste in that value that we've just grabbed. You see with debug on, you can actually see it going through every move, and then it gets to the end, and then we've correctly solved it. We've got our magic flag. So now all we need to do is go and run this against the server. Let's launch up an instance, close down some of these windows. We'll take a copy of this URL, of this address, and I'm just going to go and update then the remote value here. And I'll take a copy of that and throw that over to find sequence as well. And let's try and run this again. I'm going to turn that off debug just so it's a little bit cleaner. And we need to find sequence. Find the sequence, we get our 3 values. We'll go and find the next item in the sequence, take a copy of it, go back to solve game, paste it in. You see it takes a little bit longer once we're running it against the server, but we get our flag pretty quickly anyway. The next challenge is called Stolen Research. It's a forensics challenge, and the description says, a malicious actor has broken into a research center and has stolen some important information. Help us investigate their confiscated laptop memory dump. Note, if you need to crack passwords during this challenge, all potential passwords appear in RockU75, and the PCAP is only relevant for the last subtask, and it also tells us not to brute force the RockU75 or we'll get the IP banned. So there's a memory dump to download here and a PCAP, which we don't need until the 5th part anyway. So I've downloaded both of those. The memory dump takes a while to download. So the first part of the challenge says it's called kernel release. It says what sort of OS and kernel is the actor using. Give us the kernel release version, and that should be the output of uname-r. So we want the output of uname-r on the memory dump. So if we check the file type of the memory dump, it just shows that it's data. Let's try and have a look at the strings greater than 10. And there's a lot of strings in there. We might want to try and grep out certain keywords like password. But in this case, we're still going to get a lot of results. Let's go and have a look at some specialist tools for analyzing memory dumps. The most important of which is volatility. So I've just opened up a cheat sheet here, although there's some great documentation on the volatility GitHub, which we'll get into later because we'll need it for some of the next parts of the challenge. You can also use this auto volatility. This is something which I've used sometimes on CTFs if you just want to try and quickly just run all the plugins possible and just dump everything so that you can then go and search for flags. That's an option. In this case we're just going to use volatility, and we need to first of all determine what profile the image is, and that's essentially what we're being asked to do here as well, because it's saying find uname-r, so it's saying find out what the kernel release version is, and we basically need to do the same thing here. We need to find out what operating system it is and what profile that we'll be able to use. So we can do that with the image scan. Let me see here, as in the documentation we have image info and kdbg scan. So we'll use image info to try and determine the type of the dump. Let's try and run that now. Image info -f memdump. That took a lot longer than it looked to not find a profile, but if we go back to the cheat sheet here, we can see that we can actually download some profiles, Linux and Mac profiles, from the Volatility GitHub. We can also we can download profiles from other sources, or we can generate our own profiles, custom profiles. So let's open up a couple of links here to take a look at. So you can see here, in terms of custom profiles, in some cases, like in the case below, there may be a specific Linux version for which we have to build a profile. You can see here then we need to generate a dwarf file. So we'll have a look at this shortly, but you can see here that the actual command they've used is to just check for the Linux version here in the memory dump. So let's try and do that now. I'm just going to paste that in, and we'll change this to memdump. And this has actually come back then with the Linux version. So here's our Linux version here, 5.10.0 Kali 8 AMD 64. So if we go back to our first part of our challenge, that's the output of the uname-r. Let's compare it to what we have here in Parrot. So it's also 5.10.0, but Kali 8 instead of Parrot, instead of 6 Parrot 1. Let's have a look at the second part of the challenge as well. So the next part is, that was 25 points, this has gone up to 125 points, so quite a jump, and it's called tooling. The description says, hope you made a good custom profile in the meantime. The attacker is using some tooling for reconnaissance purposes. Give us a parent process ID, parent process ID, the process ID, and the tool name, and not the process name. So we need to give the PPID, the PID, and the tool name in capital letters by the looks of it there, separated by underscores. So that means we need to go back and have a look at this custom profile stuff and see if we can generate one. So I've jumped over to the Kali machine here, which is running on VirtualBox, and if we check the uname-r here, we'll see that we've got a slight issue. This is 5.10.0, which is good, but it's Kali 9 instead of Kali 8. So I don't want to go through everything that I tried and go through all the steps of downloading and installing everything, because it took quite a while to get this working, but there's a couple of links here which I found useful, which you could check out if you run into a similar challenge like this. But mostly the documentation on the GitHub is very useful for setting this up. One thing that we do need to do is essentially change this to Kali 8. So in order to do that, I had to download the headers from, let me grab the link here. So I had to grab the headers in here for Kali 8, and there are only certain ones we need. Let's have a look at the ones that I needed to download. So you can see here we have the common, we have the AMD 64 headers, and then we also have the image as well, and the debug. So all of these were required, and then once we have all of those downloaded, we can install them just with the sudo dpkg-i and then install all.deb. That will install them, but it doesn't change the version. We still need to reload and swap the kernel version. So to do that, we can do, well, let me just do sudo reboot now. And one thing that I found kind of annoying when doing this is whenever you boot up VirtualBox or boot up Kali in VirtualBox here, so we go into the advanced options, but it doesn't show which version of the kernel that you're actually booting up here. Hopefully, yeah, there we go. So I managed to get the Kali 8 there, but you can see that I had a lot of different versions. So now we've reloaded, let's have a look at our kernel version, and you can see now we're on Kali 8, so we're ready to go and start generating the profile. Let's go and open up the documentation. Okay, kept that open, that's handy. I'm going to go to the official GitHub here, and you can see then, so we need to do a few things. We need to install Dwarf Dump and some of the libraries. I've done all that already because you can see that I've already got everything built here on this system. So get all that installed if you need to do that locally, if you're working on this challenge or a similar challenge. And then we need to go to volatility tools. Let me follow along these steps. So cd volatility tools Linux. We need to make, and then we need to, let's do the head module.dwarf. There's our module.dwarf there. And you can see here as well the symbols contained in system map. So I did have some issues with this stage. Let me see if we have some issues here as well actually. System map is in boot, so let's cap boot system map. Do we have Kali 8? So we have Kali 7 and Kali 9, which I had before I installed those headers. So we do have Kali 8 there and it's working okay, but the issue that I did have originally was that the system map wasn't showing up, and I had to follow the steps along here to generate them. So you can see here that if you don't have the correct system map, then you can use nm on the VM Linux file. So let's locate VM Linux, and you'll see we have this file. If I run nm, that'll generate the correct system map. So you can see that I've already actually copied it over to boot, but it did have to be manually copied over. So if we follow this and let's say to desktop and system map, and that is how I produce the system map. And then once we've got a system map, we've got our dwarf file as well. We can go ahead and zip up our profile. So let's do that. Just copy this command over. So we're zipping into the profile, our module.dwarf and our system map. And then we just basically need to copy that over to our, or for me to copy it over to the Parrot VM where we're analyzing the memory dump. But if we were doing this all within Kali, we could also just use volatility in here and copy over the memory dump. But I'm going to jump back over to the Parrot system. Okay, so we're back over on Parrot. Note that I don't have volatility installed here at the moment, so I'm going to go and, I do have volatility installed, but I don't have the volatility from GitHub, which we need the profiles folder for to copy this into. So, oh well, that was the only way I was able to get this working myself. So rather than using the native version, let's git clone this. Let's go into volatility, see what we've got. I'm using the Python 2 virtual environment. There is a volatility 3, but the profile setup is a little bit different. So let's. I'm just going to use this. We'll use Python setup install, and you can see here already we have this plugins overlays. Let's go back to our guide here for the custom profiles, and you can see that what we need to do, we need to generate our profile, and then we need to copy the zip folder over to overlays Linux. So let's copy over our profile to volatility, plugins, overlays, Linux. And now let's try to run python vol.py and info, and what we're hoping to see here is the Linux profile. So scroll up past all the plugins here, and you can see we have our Windows profiles here, and we actually now have this Linux profile x64. So this is our custom Linux profile. So let's see if we can actually test this out now. You can see here we have a list of different Linux commands that we can run, and our challenge was to find a process ID, parent process ID, and name of a reconnaissance tool used by the attacker. So for that we could use one of these process lists. Let's do the aux one. So I'm going to run this. We're going to run python vol profile is equal to Linux profile x64, and then we want our memory dumps, so home desktop mem doesn't have autocomplete, so memdump.vmem, and then the command that we want to run, in this case psaux. So we get the full process list here, and we can scroll up and have a look through this to see what's of interest, but it won't take us too long to find that we have Maltego running here, which is a well-known reconnaissance tool, and we can have a look and see that our parent process ID is here 1208, and it's launching this 1082 bash command, both calling Maltego. So essentially the flag here was 1208 1082 Maltego. And the next part of the challenge says the title is password of the actor, and the challenge says what is the password of the actor. So if we go back to our volatility, let's go to the GitHub here and have a look at the documentation. We'll look at the wiki. We have command references for Linux, and in here we can go and have a look at the different commands and what they do. We have some which will sound particularly interesting, like check creds, so we're being asked to find a password here, so that might be the first thing we want to run. Let's try that. Linux check creds. Let's go back and see what else we have here as well. So we have check creds. We could also list our bash history. Where is that? Linux bash. Okay, so didn't find any creds. Let's have a look at the bash. And it did retrieve some bash commands. We can see that Maltego was called. We have password here, reboot, history, but no credentials in there anyway. We would also want to start having a look around the file system, so we can enumerate through files. Let me go back up here. Do we have a files section? So we can map memory. We have find file. It doesn't have the enumerate files option here. Let's just run this without an input, and it'll give us a list of commands available. Oh no, it won't. Okay, we need to pass in -h. So we'll get a list of commands here. Some of these commands aren't showing on the wiki. So for example, we have Linux enumerate files, which you can see there. So let's try and run that. So we've enumerated the files on the file system. We might want to output that to a text file and go and grep through for files of interest. Notice that we have an SMB share here, a server IP address, and we can see we've got the share research, which might be of interest. You can see here some trash as well. But at the moment we're trying to recover some credentials. So we've enumerated the files. Let's go and have a look here at the find file function. which it says that we can pass in -f and a file directory, a location of a file, and find out whereabouts that is in memory, the inode. And using the inode then, we can then extract that file. So why don't we try and go back, and I didn't even check the files we've enumerated there. Let's just try and use the Linux find file, and let's look for etc password. And we've got the inode, so we should be able to take a copy of this, and let's pass this with the -i flag, and then -o for the output, and then we'll just call this password. So you can see it grabs that pretty quickly. Let's have a look to see if it looks good. So we have this user Invictus, which is going to be the user we're interested in. Let's see if we can do the same thing for the shadow, which we could then use to crack the password. And then we can just grab that inode as well. By the way, if you're wondering why this is going so fast for me, it's not my computer, it's just that I'm cutting out parts of the video. It does take a while sometimes searching for files and things like that. So we'll save this to shadow. Let's have a look at it. And that also looks good, so we do have a hash here to crack. Now Kali did actually recently upgrade the hash, or change the hash format that it uses, and it's using this yes script. I believe this is a recent update anyway. It's using this yes script, which there seems to be some problems with Hashcat at the moment in terms of decrypting, in terms of cracking those hashes. So this Hashcat issues page, I did notice that John the Ripper, or the John Jumbo, does support it if you use this pass-through, this -- format equals crypt. So we'll grab this hash, take a copy of that, let's go to the desktop and just put this in a file called hash, paste that in, and then let's just run John first of all, John hash, and then we'll pass in the word list, -- word list equals rocku-75.txt. You'll see here we've got no password hashes loaded, so we need to provide this format crypt as we saw in the Hashcat GitHub issues. So let's pass that in. Let me see if we can pass it in at the end. And you can see this time it's actually trying to crack the password hash. So that took a few minutes to complete, but you can see it reliably cracked our password of security1. So we can take a copy of that and just go and input that now as our flag for the third part of the challenge, and move on to the fourth part, which says password of the share. The actor compromised sensitive credentials of the research center and used them to authenticate to a network share. What is the password of the network share they logged onto? So you'll remember that whenever we were looking through the files, we did see some mentions of a file of a share called research. So let's see if we can have a look into that. This challenge did actually take me a long time to solve. I spent a long time going through files on the file system, which I don't want to do here, but let me just show that if let's do Linux enumerate files, and I'm just going to grep out var log to see what we've got. The way I actually went through this was you can extract all the files in the file system into their relevant folders and then just browse them as you would your normal Linux file system. I'm not going to do that here because it took a long time to extract them, but that's a good way to get around the file system. What we will find though, which should have been a hint for me throughout the challenge, is that the solution for us is not going to be in the file system directly, and if we go back to this cheat sheet here on volatility, we'll see that there's a memory dump section where it says the memory dump of a process will extract everything of a current status of the process. The proc dump module will only extract the code. So we have this mem dump. For us in Linux it'll be a slightly different command which we can find here, but that's something that'll be worth bearing in mind. But obviously we need to find a process to dump in order to try and retrieve this password for the network share. So let's have a look here. We've got a syslog. Why don't we have a look at that? we can do our find file Linux find file -i -o syslog. And if we print out the syslog, we should see in here we have this command here. Okay, so Kerberos authentication with Invictus at workgroup not possible, and then we have this one here from the SMB GVSFSD SMB spawner, and it's on PID 1315. So if we wanted to try and perform the dump that I mentioned there, in order to do that in Linux, we can do that as follows. We'll use Linux dump map -p and then the process ID, which in this case is 1315. We try to run that and it's going to come back with an error saying we need to provide a directory. So let's make a new directory and let's provide that with -d dump, and this will extract a lot of different files for us. So the reason this took me so long is because I was dumping a lot of different processes, including this one, but look how many files there are to go through. And if we go, let's go to the dump directory. So we have all these files in here. We can check the file type, we can have a look at the strings, but we do have a lot in here. So again, we might want to start grepping for things, and this is essentially what I did, was find that if we grep for let's grep for research, and we have some files here which match. So I essentially went through each one, and let's run strings-n10 grep research, any which looked interesting. So you can see these strings in here which look interesting. Let's try and let's send this to a file. Let's just call that temp, and we'll open that up and essentially just go through. I went through each one at a time and looked for things like research and things like password, the IP address of the share as well, until we find something. It doesn't look like this is the right one. Let's try that with a second file as well. And again, have a look for research. Doesn't look like any passwords. I did have a look for these hashes and see if anything was just in hex encoding. Let's try the third file. You could really just run the strings on all 5 of these files, I guess, but I'm going to go through each one. We have plenty of research here, and we also have some mentions of password here as well. Retype password, enter new password. And just as we're going through this, look, we have this password here, or we have a string which looks like a password, shuttle 9812983. So I grabbed this password, grabbed that word when I saw it, and submitted that as a password, and that was the correct password. So the 5th part of the challenge is worth 250 points. This is 5 times the points of the previous challenge. So stolen information. Unfortunately, it looks like some very sensitive information was stolen. Can you recover it? And we have this stolen PCAP, which we know is part of this challenge, and it does say that it's relevant only for the last challenge. It doesn't mention whether the memory dump is also relevant for the last part of the challenge, which led me down some rabbit holes. So let's go and open up this PCAP, see what's going on. If we open it up, the first thing I like to do is just go and have a quick look at the file properties, find out what kind of PCAP we're dealing with here. It was captured for 2 minutes, it's got 653 packets, and we can see it was captured in July, the 1st July. We can go in and have a look at the protocol hierarchy as well and just see what kind of data we're dealing with. In this case, mostly SMB data. We have 1 UDP packet which we might want to go and check out. Doesn't look of interest. So let's just go and start scrolling through here and see what we see. We can see all these encrypted SMB packets which we're not able to filter by. We have our protocol requests at the beginning. Let's have a look here. Okay. We can see the IP address there. So essentially what I did at this point was go and have a look, can we decrypt SMB3, decrypt Wireshark? I'm going to show you a couple of the kind of rabbit holes that I went into before showing how I solved the challenge. So there's a couple of articles here, and this PDF document as well was actually, so there's a PDF presentation here about decrypting. Well, it has some information about different features available in Wireshark in the new version of Wireshark, but you can see here that Wireshark can decrypt SMB3 traffic, and it must have the initial connection steps. The user must provide a session key, and this is how we get the session key. So I was wondering whether we would need to grab some of this from the dump, and that was one of the rabbit holes I was going into. You can see here if we go into the protocols in Wireshark, we can actually add some of this information. Let's go and have a look at that. So we go to protocols, and then this is how you would normally do the same for decrypting SSL and stuff as well. So we go to SMB2, and you can see here we've got the secret session keys for decryption. So we want to put in a session ID and a session key. I couldn't find a service client or a client to server, but it doesn't look like we need it anyway. Let me just go back and see where we can find this. So we want to go through to our protocol requests, and right here we have the setup request. If we go in here and just drill down on this SMB protocol info, you'll see that we have our session ID right here. So we don't need the 0x, but it's this B06D value. And then we also have somewhere we also have a session key right here, B35056. So I'm going to basically go back to the preferences and back to our protocols. Let's go and try and input this into the SMB2 section. So we need to add a new one. I'll just copy and paste this from my earlier notes. There's our session ID, which we just saw, and then here's our session key as well. So we paste that in. That's enough for us to click OK and go back and see if we can have a look at the encrypted SMB data. Notice that we can't have a look at the encrypted SMB data, but the packet capture is looking a little bit different. So whenever I was solving this, I didn't actually realize that that had made a difference, because we still have all these encrypted SMB stuff. So at that point I started looking into alternative solutions, and I was interested in this NTLM SSP stuff and found that actually there is a tool which can extract these hashes from packets. So let's just go and open up this GitHub link. So there's a tool, NTLM raw unhide, and if I'll download this now into let's just git clone this, and I'm going to run Python 3 NTLM raw unhide. Let me just minimize this so you can see it a bit better. And NTLM raw unhide, and then we just need to pass in the packet capture stolen.pcapng, and you can actually see it very quickly recovers our hash. So at this point I threw this hash into Hashcat and started trying to crack it, but while I was doing that I was also looking into providing the passwords and the protocols in Wireshark. And actually if we go to, let's go back to edit preferences, let's go back to our protocols, and this time let's have a look for NTLM. You see here we've got NTLM SSP. Let's try and enter in our password Shuttle, which was from the last part of the challenge. Hit OK. Is anything looking different here? It doesn't look like it at the moment. Let's try and just close this down and open it up again. That's interesting. So it turns out that the solution that I thought had solved it for me wasn't the solution initially. So although we've entered in the SMB session key and session ID, and we've entered in that NTLM password, we still don't have the decrypted data. So I'm just going to go back to another article which I used whenever I was trying to solve the challenge initially. The problem is when you're trying to do so many things at once, sometimes things just start working and you're not sure exactly what you did to fix it. It looks like then what I did earlier to get this working was changing the protocol settings for the Kerberos. So let's go and have a look at that now. Go into Preferences, Protocols, KRB5, and then you see we have here try to decrypt the Kerberos blobs. There we go. Click OK, and you can see that now we've actually got decrypted SMB packets. So we could go and start looking through these and see what's going on. The first thing I did here was to export objects SMB. You can see that we have all of our share objects here, so I'm just going to save them all to the desktop. Let's close this down, and now you can see we have these images. One of them is this image here, which has CTF, Secret Research Facility, as the flag. And that's the fifth and final part of the forensics challenge solved.